In the first lesson on hybrid orbitals, we did linear geometries, trigonal planar geometry, and tetrahedral. Now we're going to do trigonal bipyramidal. And these are going to be ones that allow more than 8 electrons around the central atom. The first one is phosphorus pentachloride, PCl5. Let's look at phosphorus again. It's got 2 dots that are together, one by itself, one by itself, one by itself. In order for it to do more than 4 bonds, we are going to have to split these apart. So it's an S2P3 atomic orbitals. So I'll put 2 electrons together, one by itself, one by itself, one by itself. But it's also a D0. And remember, there are 5 orbitals there. 1, 2, 3, 4, 5. Now what if we were to take 1 electron from here and place it in the empty d orbital? We would end up with an S1 P3 D1 hybrid. And that's 5 total orbitals. 1, 2, 3, 4, 5. Now remember, that means we've hybridized 1 s orbital, 3 p orbitals, and 1 d orbital. So then we have an arrow up, arrow up, arrow up. So we have 5 arrows up. That would correlate to something that looks like this: phosphorus with 1 dot, and then 1 dot, and then I'm going to try to draw these in trigonal planar. Okay, now we can put the chlorine atoms here. So I'll put Cl here, another chlorine here, another chlorine here, 1 here, and 1 here. Now I will need to complete the octets for all the chlorines because they start with 7 electrons. So each chlorine will now have 8 electrons around it. And try to complete this so it looks good. Okay, so let's take a look at what it looks like in 3 dimensions. It's called trigonal bipyramidal. We have the trigonal shape here. Then we had an extra bond on top and an extra bond on the bottom. There's 90 degrees between these two and 120 degrees along the planar. So if we look at phosphorus now, it does have 10 electrons, or 5 pairs, around itself. And that's how trigonal bipyramidal happens. Let's look at our final shape, our geometry. Sulfur hexafluoride. If we look at sulfur, its ending configuration and dot diagram looks like this. It's an S2P4. So arrow up and then arrow down. Arrow up, arrow down, and then up and up. Let's also write the D0 in here. And there's 5 orbitals there. 1, 2, 3, 4, 5. So we can promote 1 electron from here into this d orbital, 1 electron from here into this d orbital, and then we have an S1 P3 D2 hybrid orbital system. Now remember, that means 1 s orbital, 3 p orbitals, and 2 d orbitals are involved. And that'll be 6 total orbitals that are involved in the hybrid. So we have an arrow up, arrow up, arrow up, arrow up, arrow up, and then arrow up. The flat diagram would look something like this. I will try. So there's going to be 1 here. I will just do 1 here, and then I'll try to do 4 across there like that. Now let's attach the fluorines one at a time. So fluorine here, a fluorine there, 1 here, 1 here, that's an F there. There's a fluorine here, and a fluorine here. Let's complete the outer octets of the fluorines. Takes a while to do this. All right, there was my attempt to do that. Once we look at this right here, we see that the sulfur is in the middle here, and each one of these are the fluorines. And there's 90 degrees between all of them. You've probably played jacks before. You bounce the ball and then grab the jack. So this is exactly what a jack looks like. It's an octahedral. Okay, so those are the two last geometries. And if there's a bond missing, then the geometry and the shapes will not be identical towards each other. And that'll be what we talk about in our lesson that follows. But again, that's the basic idea between our two, what I call hyperbonds. They're more than 8 electrons in the outer level for the central atom.